Hello, my dear students. Today we will discuss about the moments. Basically, moments are the statistical tools to measure the characteristics of the given data. So, basically, two moments are of three types. Number one, moments about mean and also known as central moments, denoted by mu r. Number two, moments about arbitrary points in some books written as small a or capital A, or raw moments, and it is noted by mu dash r. And the third one is moment about origin mu r. Okay, moment about origin denoted by mu r. So basically these three types of moments. So we discuss about the formula of all three types. So first of all, number one, for individual series means there is only number of observations like x1, x2, xn. x1, x2 up to xn are the observations. So mu r is equal to 1 upon a small n. What is small n? A small n is the number of observations. 1 upon n summation I varies from 1 to n x I minus x bar to the power r. So this is known as rth central moment or rth moment about mean. Mu dash r means rth moment about arbitrary point or rth raw moment. So this is defined as 1 upon n summation I varies from 1 to n x I minus a to the power r. And the last one is nu r. Nu r is the moment about origin. Means rth moment about origin denoted by nu r and defined as 1 upon n summation I varies from 1 to n x I to the power r. These formulas for the individual series. Now, if the frequency distribution, it means that there are number of observations with corresponding frequencies f1, f2 up to fn. So the formula of mu r, rth central moment for the frequency distribution, is defined as 1 upon capital N into summation I varies from 1 to n fi into xi minus x bar to the power r. Here capital N is the sum of all the frequencies. It means this can be written as capital N is summation I varies from 1 to n fi. Sum of all the frequencies is denoted by capital N. Mu dash r, rth moment about arbitrary point for frequency distribution, is denoted by mu dash r and is defined as the formula 1 upon capital N summation I varies from 1 to n fi into xi minus a to the power r. And the last one, nu r, rth moment about origin for the frequency distribution, is denoted as nu r and defined as 1 upon capital N summation I varies from 1 to n fi into xi to the power r. Okay. Now we put the value of r, like r equal to 1, r equal to 2, r equal to 3, r equal to 4. Generally, we calculate the fourth moment. First four moment, mu 1, mu 2, mu 3, mu 4, mu dash 1, mu dash 2, mu dash 3, mu dash 4, and mu 1, mu 2, mu 3, mu 4. Generally, we calculate only first four moments because we use the first four moments to measure the skewness and measure the kurtosis for the given distribution. So basically we use the frequency distribution formula. So we calculate first of all r is equal to 1. If we put r is equal to 1 in this formula, mu r, so this is mu1 1 upon capital N summation I varies from 1 to n fi xi minus x bar to the power 1. So here 1 upon capital N summation I varies from 1 to n fi xi, if we open the summation, open this bracket with the summation minus 1 upon n, x bar is the constant, so we put before the summation, so this summation I varies from 1 to n fi. Okay, so now 1 upon capital N summation fi xi is the mean, is the formula for the mean of the frequency distribution. So this can be written as x bar. X bar is the mean of this frequency distribution minus 1 upon n x bar into capital N, because summation fi is denoted as capital N. Okay, so now here capital N and capital N both are the cancelled, so x bar minus x bar, this will be equal to 0. So we can put the result mu1 is equal to 0. Mu1 is equal to 0, it means mu1 it means first central moment or first moment about mean is always 0 for any kind of distribution. Similarly, we can find the another moments mu2, mu3, mu4 and so on like this. If we put r is equal to 2, so we calculate mu2 is 1 upon n summation I varies from 1 to n fi xi minus x bar to the power r. Sorry, to the power 2. So this is the mu2, and mu2 is also known as variance of the given distribution. If we calculate the standard deviation, so we put the square root of the variance or square root of the moment, second central moment or second moment about mean, mu2. Square root of mu2 is the standard deviation. So similarly, we find the mu3 with this formula 1 upon n summation I varies from 1 to n fi xi minus x bar to the power 3. Mu4 1 upon capital N summation I varies from 1 to n fi xi minus x bar to the power 4 and so on and so on. Okay, so these are the first four central moments or first four moment about mean. Now first four raw moments or moment about arbitrary point. Now we calculate. If r is equal to 1, so mu dash 1 first moment about arbitrary point, mu dash 1 is equal to 1 upon capital N summation I varies from 1 to n fi xi minus a to the power 1. So we can open this bracket, 1 upon capital N summation I varies from 1 to n xi minus 1 upon n summation fi into a. So here 1 upon capital N summation fi xi is the mean, it means x bar, minus summation 1 upon n into summation fi is written as capital N into a. Capital N and capital N are cancelled, so mu x bar minus a. So this is first moment about arbitrary point. Mu dash 1 is equal to x bar minus a. Okay, where a is the arbitrary point and x bar is the mean of the given frequency distribution. Now we put r is equal to 2 in this formula. Mu dash r is equal to 2. So mu dash 2 is equal to 1 upon capital N summation I varies from 1 to n xi minus a to the power 2. Similarly, we can calculate mu dash 3 and mu dash 4. We put the r is equal to 3 and r is equal to 4 in this formula mu dash r, and so on and so on. Okay. Next, nu r, moment about origin. Now we put r is equal to 1. Nu 1 is 1 upon capital N summation I varies from 1 to n fi xi to the power 1, and this is known as mean of the frequency distribution. So this can be written as simply x bar. So first moment about origin is equal to mean of the given frequency distribution. Similarly, we find the mu 2 1 upon capital N summation I varies from 1 to n x fi xi square. Similarly, we also calculate nu 3, nu 4 and so on. Some other moment about origin. The most important thing, what are the values of moment about mean, moment about arbitrary point, moment about origin at r is equal to 0. So now we calculate for r is equal to 0 for both these three formulas. If r equal to 0, now we calculate nu 0. Nu 0 means 1 upon capital N summation fi I varies from 1 to n into x minus x bar to the power 0. If any finite value to the power 0 is equal to 1. So that's why this can be written as 1 upon capital N summation fi 1 n upon n is equal to 1. So mu 0 is equal to 1. Mu 0 is equal to 1. So we can use the value of I, the value of mu 0 is directly used in the given problems. Now we calculate mu dash 0. So mu dash 0 is 1 upon capital N summation fi xi minus a to the power 0. So this is also 1 upon capital N summation fi. So this is also equal to 1. So mu dash 0 is also equal to 1. Okay. Then next and the last one is nu 0. What is nu 0? Nu 0 is 1 upon capital N summation I varies from 1 to n fi xi to the power 0. So this is also 1 upon n summation fi. This will be also equal to 1. It means mu 0 is equal to 1. Mu 0 is equal to 1 and mu dash 0 is equal to 1. So we see here if r is equal to 0, so mu 0, mu dash 0, mu 0 all are equal to 1. But this is not our first movements. First movements are starting from r is equal to 1. Okay, if we put r equal to 1 in these formula, so these are the first movements. Second movements if you put r equal to 2, third movements if you put r equal to 3, fourth movement if you put r equal to 4. So generally we calculate first 4 movements for the r equal to 1, r equal to 2, r equal to 3, r equal to 4. Basically we calculate only first 4 movements. Okay, so we stop here in this lecture, and in next lecture we will discuss about the relation between moment about mean and moment about arbitrary point. First relation, and the second relation, moment about mean and moment about origin. Okay, and there are some other problems based on the moments discussion. They will be discussed in next lecture. So thank you very much. Bye bye.